Hello, Nicomatic sales team. This is Phil. Today we're going to talk a little bit about the end preparation for ZIF and LIF connectors. You know about our exposed and stiffener lengths, but maybe we talk about why they are what they are and talk a little bit about what we see from customer inquiries. First, and from a standard print, you know everything about our lengths and widths and pitch. There's an exposed length area and, of course, a stiffener area that has to be part of our standard part numbering, and they are, and we've come up with some standards to go along with it. Again, this construction that we talk about showing exposed and stiffener, we'll show this diagram again when we talk about mating thickness, but today we're just going to talk about exposed and stiffener. First, I want to just point out to you that when we put an exposed window into our polyester, it's done on a moving web of material. So, getting precise locations of that is not always right on the number. So we have tolerances on the exposed window. Similar on the stiffener, it's put across the web on a moving target, so there are tolerances implicit into that dimension. So what are those tolerances? Well, we have tolerances for lengths and widths, etc., but the exposed conductors are plus or minus a millimeter. That's just the reality of the circumstances. Stiffeners, 1.5 millimeters. So when we talk about, a customer's demand for a product, why do they come up with those numbers? And basically they come up with those numbers because of the connector they're mating to. And, here's an example of a listing of some ZIF and LIF connectors where you'll have exposed conductor lengths of 3 millimeters or 2 or 4 or 3.5, and of course a stiffener length. Those are for the ideal circumstances, but that exposed conductor is something that we're very, very critical of. So if you take a look on a 0.5 millimeter connector and you note that our exposed conductor is 4 millimeter, well, with our plus or minus 1 millimeter, it hits right into those numbers. So here's a good example of it. This is an Omron design for their connector. You take a look at this exposed area. It's 2.5, but note that word min. So they're not looking for 2.5 as a nominal. They're looking for that as a min. So with our tolerances, we always can hit that. Same thing with the stiffener material. Just to show you, here's a 1 millimeter cater from JST. They're 3.3 exposed min. So on 1 millimeter, our exposed is 5, and with that tolerance, we're always going to be in there. So these things have become very, very important. And just to fill out the equation, here's an Hiroshi with their Hiroshi tabs. They are also talking about 3.5 min on their exposed areas. So, the reason for this is basically because we get a lot of customers saying that they want a 3.5 exposed or a 3 millimeter exposed and don't want it to stay with our standards. You need to help educate them to say that stay within a standard exposed from the Nicomatic solution. It will work with their connector. And also watch when the stiffener and the exposed are the same length. What will happen there is those tolerances can create a very dangerous circumstance where the stiffener is shorter than the exposed. So help your customers. Make sure you point out to them that stay within the standards is the least expensive way of going, and they will always get the right solution.